Hello everyone. In this video, we will be discussing about service discovery in microservices. Let's get started. In a monolith or a simple application running on a single instance, it is very easy to request and get a response. Let's say you have been running a monolith or a very simple application which has just one server or one instance. It is very easy to request and get response. You just send a request and then you get a response, and that's all. But as our application grows, it becomes complex. Then we start having auto scaling or manual scaling and happen to get multiple instances of server running. That means as our service grows very complex, we start having auto scaling. As the traffic to our service increases, we increase the number of servers. And as the traffic to our services go down, we start decreasing the number of servers to have a cost cutting and efficiency. So these servers can go down and new ones can be spinned up. Let's say your servers are being modeled as a Kubernetes pods. So these pods are ephemeral. They can be dyed, they can be recreated, right? So they can go down anytime and new ones will be spinning up. How does one microservice know where the other microservice is located and how to call it? This is the whole concept of service discovery, from where one microservice gets to know where the other microservice is located. Let's say the microservice 1 wants to know the IP of the microservice 2 so that microservice 1 can call microservice 2. Whenever a server comes and goes, Service Registry, also known as Discovery Server, will note it down, which is itself a microservice. It stores all running servers and their running locations inside it. So it can be better called as Location Service Registry. That means that this service registry will hold something like server 1 is running on which IP. Server 2 is running on which IP. It is kind of a dictionary where it stores all the running servers and their running locations. That means you can consider them as IP or port. The load balancer will talk to service registry to decide where to route the traffic. For example, you are sending a request. Let's say you are sending a request to load balancer. Now load balancer will be doing the load balancing among, let's say there are 3 servers up, but it has to know what is the IP on which each server is running. So it will first talk to service registry. It will get to know that, okay, there are 3 servers, 1, 2, 3, which have IP1, IP2, and IP3 respectively. This response is obtained by load balancer from service registry, and let's say it has chosen server 1 to handle the request. So this is the importance of service registry, which is basically aiding the load balancer. Example is when we want to order, let's say you want to order pav bhaji. You just Google it and then use the phone numbers to call and place order. Here, Google is acting as a service discovery server, which is giving you the phone number similar to IP of a restaurant. Restaurant is similar to a service. The restaurant was registered with Google. So Google knows that for this restaurant, this is the phone number. For other restaurant, this is the phone number. And when you search pav bhaji, this is a kind of a request, right? So you will get each restaurant's phone number on which you can use or decide which restaurant to call. Say a new server is added, let's say server 4. So now we have a server 4 as well in the picture to handle increased load. Let's say there was some auto scaling. You might have heard of auto scaling groups, ASGs in AWS. This is similar to that. So a new server has been spinned up to handle increased load in the, let's say, peak traffic or festival seasons. Then it will be registered in the service registry. So this entry has been done in the service registry. Same path is followed where the client sends a request to load balancer gets to know what all servers are there, what are their IPs, and then it chooses one of the servers based on some algorithm. Let's say round robin or maybe list load. If you want me to make a video on load balancing and its strategies, please feel free to comment in the video, and I will be making a video on that soon. Now suppose server 2 crashed. So this server has gone down. Maybe let's say there was some out of memory exception, or some resource crunch was there, or some power failure, or it was deliberately killed. So this information will be updated in the service registry. So this entry you see, entry for 2 is gone. How does service registry gets to know whether some server is coming up or some server is coming down? The basic idea is the concept of a heartbeat. So at a high level, heartbeat is nothing, but it is a way to tell the server or service registry that this server is alive. Is alive. So this is alive is basically nothing but a message to the service registry that I am alive. Once, let's say, some network glitch happened, or due to some power failure, the heartbeat could not reach the service registry, it will wait for some time, and it will keep retrying as well in case it was just a temporary or transitional network failure. To overcome that, once it gets to know that okay, for certain amount of time heartbeat has not been received, it will assume that server 2 is dead, and it will remove the entry from the service registry cache. This process of registry and then talking to registry and get IP address is called server side discovery. But service registry is a single point of failure. To prevent this, load balancer can also cache the data of the registry. So this data, which is basically on the service registry, can also be cached on the load balancing side, so that if service registry goes down, which is a single point of failure, in that case load balancer can use the cache data, the cached table, to route the requests. So if service registry goes down, load balancer can be by the cache data. So we talked about server side service discovery. Similarly, we have something known as client side service discovery. And what are the examples of these? So for the client side service discovery, Netflix Eureka is a very popular solution. And for the server side service discovery, we have Nginx. This is read as Nginx. So that's all. In this video, we talked about what a service discovery is, what are its applications, some of the examples, then what is the difference between a server-side service discovery and a client-side service discovery, and couple of popular solutions for the client-side and server-side service discovery. Thank you so much.